8.3 is scale diagrams. So a scale drawing is a reproduction of a diagram of something that we either want to enlarge or reduce in size. It's either larger or smaller than the original, but it has the same shape. It's going to be a similar figure, so the sides will be proportionate, but I'm either going to be multiplying it by a number larger than 1 to get an enlargement, or reducing it by multiplying it by a number less than 1. Each dimension of the figure is multiplied by the same scale factor, meaning both objects are proportionate to each other. In order to visualize the actual figure, you need to know the scale of the scale drawing. You will need to use ratios and convert measurement units. So there's 4 different ways that a scale diagram can be specified that we can identify what it will be. So that's if I just say it's a statement, saying it's 1 centimeter is 50 kilometers. So you would see this quite often on a map in terms of the distance that you would actually measure on a map in comparison to what it is in real life. A rate, again, we've talked about that. So a rate is comparing 2 different units, so 1 centimeter to 50 kilometers. I could write it as a fraction like that. A ratio has to be in the same units, comparing the same things. So we're converting 50 kilometers to centimeters so that I'm comparing the exact same unit. So 1 centimeter is 5 million centimeters. Or I can do it as a linear scale, which is a visual like that. That one's less common with what we'll be doing our work in, but all of those 4 ways we could represent what our scale diagram is. So, example. Complete the table. So object length, image length, we need to identify our scale factor and state whether or not it was an enlargement or a reduction. So scale factor is always your new image over the object that you started with. So I also say new over original, whichever way helps you there. So my new image is 14, I started with 7. So image over original object, so my scale factor is 2. When your scale factor is greater than 1, it's an enlargement. I started with 7, now that same side length's of 14, so I know that it was an enlargement. My new image should be larger than the one I started with. My object length for the second one, 15 inches to 5 inches, so my new one's 5, but I started with 15, so my scale factor is 1 over 3. My scale factor is less than 1, it's a fraction, so my new image is a reduction. Now these ones are a little bit different. We're given our scale factor and our image length in this first one. What did we start with? So what did I multiply by 1.5 in order to get 6? So we'll need to do some work for that one. So 6 over, so image length over your object. So 6 over what object gave me 1.5? You can say over 1. So that's just going to be cross multiplying. 1.5x equals 6 divided by 1.5. 6 divided by 1.5 is 4. So 4 and then same units, 4 meters. If I started with 4, got 6, this must be an enlargement. And my scale factor is greater than 1, so I also know I'm getting a larger new image. In the last one, I'm starting with 8 feet. My scale factor is 0.4. What would my new image length be? So what is my new if I started with 8 and my scale factor is 0.4? Just multiplying, oops, that shouldn't be an x, that should be a 1. Cross multiplying, x is 8 times 0.4, which is 3.2. And we are in feet. My scale factor is less than 1, so it's going to be a reduction, and we can tell we started with an 8, ended up with 3.2, so our image is smaller. Example 2. Surveyors are using a measuring device called a tight chain to determine boundaries of plots of land. Two surveyors determined that a proposed building site is rectangular, measuring 175 meters by 50 meters. To make a scale drawing of the site, they use a scale of 1 to 2500. What are the dimensions of the scale drawing of the building site in centimeters? So what 1 to 2500 means is 1 unit on the image is 2500 units on the object. So if you want to write that out as a reminder to yourself, 1 unit on the image is 2500 units on the object. So what are the dimensions of the scale drawing of the building site in centimeters? So if my drawing in real life story is 175 meters, what am I going to have? What's it going to be on my actual drawing? So object times your scale factor equals your image is the formula we're going to use here. Times your scale factor will give you your image. So the object we are starting with is 175 meters times a scale factor of 1 over 2500 equals 0.07 meters, which is in the same units as above. It does ask us though to answer in centimeters because if we're going to draw on paper, we're probably not going to measure things in terms of meters and have 0.07 meters. We would divide that by, or multiply that by 100, sorry, to convert that to centimeters. So times 100 centimeters in 1 meter. Move your decimal 2 places, 7 centimeters. Now the second one, so my second dimension was 50 meters, same thing. 50 meters times my scale factor gives me 0.02 meters, but I want to draw in centimeters, which will be 2 centimeters when you move your decimal 2 places to the right. Those are my new dimensions for my drawing, for my image. B says use a metric ruler to accurately draw the scale drawings. So here's my ruler. I need 7 centimeters by 2 centimeters. So 7 centimeters, about there, and by 2 centimeters. I think I went over a little bit. Spin it back. Seven. By 2. So yours will be more accurate than what mine will be. And then maybe just labeling your dimensions, 7 centimeters and by 2 centimeters. Example 3, a dollhouse is 1 to 10, so 1/10 of the actual size of the house. If a chair in the dollhouse is 2.75 centimeters tall, how tall is the actual chair that it models? So again, object times your scale factor would give you your image. I'm looking for what was my object originally. So to solve for your object, you'll divide both of these by your scale factor. So our object is equal to our image divided by our scale factor. So what is my object if my image was 2.75 centimeters and my scale factor is 1/10? 27.5 centimeters in real life. Example 4, Johanna designs the logo shown for an environment club. She wants to enlarge the logo so that it can be applied to the front of a baseball cap. She initially thinks of using a scale factor of 300%. Part A says draw the logo using this scale factor and then determine is this a good scale factor for a baseball cap. So the dimensions are hard to read in your notes there, but it's 1 centimeter and it's all by ones. 1 centimeter, 1, 1. That's what all those numbers say. So a scale factor, if it's 300%, so 300 out of 100% originally is really just 3/1, or times 3, or scale factors of 3. So all of those dimensions in our drawing need to be 3 centimeters by 3 by 3 by 3 all the way around. So I need my ruler again and a compass. So I just drew my circle so that it lines up with 3 centimeters for a radius there in that inner circle. And then I need 3 centimeters on the outside, so this will reach to 6. Maybe I'll put it back. First, move it up over to 6. So that's 3 centimeters inside and 3 outside, so 3 to 6. Draw my circle around there. So this distance is 3 centimeters, just like the drawing. This distance is 3 centimeters, just kind of replicating the drawing that we were given. So that is the drawing similarly, where my new radius is 3 and the width of the outside circle is 3 as well. So here is the logo. See if you can see all of that. Using the scale factor of 300%. So I tripled what my original was. And then B says, is this a good scale factor for a baseball cap? So if this is really the size, this is not going to fit on a hat, right? If I do 3 by 3 by 3. So no, it's too big to fit on a cap, you would say for B. Not a good scale factor. Example 5, a portrait measures 50 centimeters by 35 centimeters. The larger side of a reduction of it measures 20 centimeters. What is the scale factor of the reduction? So we need to again make sure we're comparing corresponding sides. So if the larger side of the reduction is 20, then it must have been 20 that was compared with 50, if it's the larger side, because 35 using the same scale factor should be less than 20, as it won't be the larger side. So what's the scale factor? So scale factor, again, is your image, your new one over your original object. So what scale was used if my image gave me 20, but originally that same side was a 50? Simplified 2/5, or you could say 0.4. So we know it's a reduction because my scale factor is less than 1, and also we can see we started with 50 and now we're down to 20. So that is our scale factor. Then B asks us, what is the length of the shorter side of the reduction? So A answered our scale factor as 0.4. B, the length of the shorter side is object times your scale factor will give you your image side. So my object originally was 35 times my scale factor of 0.4 will give me my new image length. 35 times 0.4 is 14 centimeters. So in this section, you're just identifying scale factors, working with scale factors to find maybe what the new image would be when you know the scale factor, or if you're given your new image size with your scale factor, what was your original dimensions. Your assignment is here on page 479. Numbers 1 to 4, 5 to 9, 12, and 14. Let me know if you need any help.